In this lecture, useful for GATE and SSC JE as a part of hydrostatic pressures in hydraulics or fluid mechanics, it is the 21st lecture. I want to discuss on the hydrostatic forces on curved surfaces. In the last class, we have had an example about the hydrostatic forces on vertically fully submerged vertical surfaces, plane surfaces, that is rectangular surface we had. Now we will consider partially submerged curved surface. What happens now? It is a very interesting subject, very interesting question. I have framed one good question after reading the various resources of the level of engineering services examination or GATE or SSC JE. Please listen to it. You will gain some concepts and insights of the hydrostatic forces on curved surfaces. We will go with some suitable example so that you will understand better and appreciate better the theory instead of only talking about the theory. Let there be a question like this: let there be a sector gate. Sector gate means there is a gate on the crest of the spillway. Spillway is there. Above that spillway, a sector gate is there. Spillway will be like this and gate will be like this. Sector means circle is there. Within the circle, for example, if I take a portion of the circle like this is called as the sector theta. This is part of the circle. Sector, this is called as the sector, part of the circle. This theta can be 45 degree, 60 degree, 30 degree, that is up to you, how much sector. This total circle is of 360 degrees, on which we will be taking a part of the sector in such a way. This is another theta. Theta is equal to 45 means 2 theta is equal to 90. This total is sector and 2 theta is equal to 120 degrees. 2 theta is equal to 60 degrees. This is the sector. Why I wanted to give this information priorly? Because many people may not be aware if I say that sector gate. A sector gate is a gate. A circle is divided into sectors of 30 degree, sectors of 45 degree, sectors of 60 degree. That means this is the horizontal line and a part of the circle is taken like this. Then this is theta, this is theta, 2 theta is the angle of sector and half of 1 theta goes above the horizontal line, 1 theta goes below the horizontal line. Now, and it is the spillway, spillway is like this, and above the spillway you can have, spillway is constructed, above the spillway you can have a gate. This is the gate. This is the background of hydrostatic structures about gates, spillways and sector gates. Now, we will go for the real question. Let us say there is a sector gate of 60 degree, that is equal to 2 theta. 2 theta is equal to 60 degrees. Angle of the sector is 2 theta is angle of sector. Angle of sector is 60 degrees. That means one side it is 30 and another side it is 30. Now, there is a spillway and this gate has a width, some width. Gate definitely will have a width, definitely, and the sector will have, is a part of the circle. The circle will have a radius. Let the sector gate radius is equal to 20 meters. Let us say sector gate radius is 20 meters. We can say something lesser because 20 meters will be very big. Let us say about some 6 meters. Width of the sector gate will have a width about 20 meters. Because this is a spillway, please try to understand. You can also frame your own questions, there is no problem. Gate problems, very important, many times asked in GATE, SSC JE and also in engineering services examination. This hydrostatic forces on gates is a very important topic in civil engineering. Let us say this is the sector gate, this angle is 30 and this angle is 30, 2 theta is 60. Now, up to this water is filled. This is water, only half filled. The sector gate is not fully immersed, the sector gate is half filled. This is the water level. Width of the gate, that means the gate has a big width. Width can be 20 meters, 10 meters, depending upon the requirement in the field. Width is like this, 20 meters, that gate width can be 20 meters, 10 meters, depending upon the requirement at the physical field structure. This type of gate is made on this spillway. This is the spillway. And because it is a circle, the circle is of this shape. This is 60 degrees, the circle is of this shape, and sector gate radius is 6 meters. What is given? Sector gate radius is 6 meters. Width of the sector gate, it will not be presently useful for us. At the time of calculation of force, it will be useful. For understanding, the 6 meters is the sector radius, that is the circle radius, and 30 degrees is the total internal sector angle. On one side, total angle is 60 degrees, 2 theta, and width of the sector is 20 meters. Water is filled up to half of the height. This height we are not aware. This is A, this is B, this is C, this is D, and this is O. Now we have to find out hydrostatic force on the gate. As a first part in this lecture, we will be finding out horizontal, because curved surfaces will have both horizontal and vertical forces. Find horizontal force on the surface. Let us find out first that one. Did you understand the problem? Now we will go into the problem solution. What is given? Let us draw a diagram here. This is the circle and this is the angle. This angle is 30 and this angle is 30 degrees, because 2 theta is 60 degrees. And what we have to find out? B, D is the height up to which water is available. This is the water column. Water pressure will be like this on the surface. This is a curved surface. Please remember, water pressure will be like that, force will be like that. That means the force will be like a triangle for any vertical surface. For any vertical surface, please see that this is like a triangle. Geometry will apply afterwards. Force acts like this, horizontal force. We are calculating the horizontal force on the surface as of now. Now for finding the horizontal force, we require the height, BD. Whatever may be the shape of the surface, from fluid mechanics basics, you please refer to my earlier lectures. Pressure is equal to rho GH, horizontal pressure. Then this pressure rho GH is acting on BD, because water height is only half. Water height, it is given, water height is equal to half of the sector gate height. Water height is BD, that means rho G into BD. It is given as 6 meters. It is given as 30 degrees angle. Can we find out BD? What is from trigonometry? From trigonometry, opposite side by hypotenuse is equal to sin theta. Opposite side by hypotenuse is equal to sin theta. That implies sin 30 is equal to, what is the opposite side to the angle? That is BD. Hypotenuse is AD. Is it correct? BC. Instead of BD, you call it by any name, no problem. BC by AC is equal to sin 30. It is not BD, we will call it as BC. You call it by any name, no problem. The actual height is required. Sin 30 is equal to BC by AC. That implies BC is equal to AC into sin 30. What is AC? AC is given as 6 meters. 6 meters into sin 30 is a half. That is 3 meters. This BC we have got it as 3 meters. Water height is equal to 3 meters. Water height is equal to 3 meters. Therefore, pressure at the bottom of the gate is equal to rho G into BC, that is equal to rho is 1000, G is 9.81 into BC is 3 meters. What it will be? You please see what is the value of it. 1000 into 9.81 into 1000 into 9.81 into 3. That you can do even with without calculator also. 29,430 newtons per square meter. Then what is the area? Cross sectional area is equal to width into height of water column. What is the width? Width is given how much? 20 meters. 20 into height is 3, that is equal to 60 square meter. Therefore, total horizontal force is equal to acting on the surface pressure into area this pressure is pressure at the bottom of the gate. At the top of the gate, because we have to calculate the average pressure. Pressure at top of the gate is 0. This is average pressure we have to take, because pressure diagram is like this. At the top it is 0, at the bottom 29,430. That means the average of it, half into the area of the triangle, rather half into 29,430 into 60. Now you please calculate 0.5 into 29,430 into 60. $880 to 900. Total horizontal force is equal to 880 to 900 newtons. That is equal to 882.9 kilonewtons, or you can even say 0.8829 meganewtons. If in newtons asked, answer this you give, meganewtons is asked, you can give that, and if in kilonewtons means, you can give this. What is the height of the water column we have found? 3 meters. What is the pressure at the top? It is 0. What is the pressure at the bottom? We have got some value, rho GH. And what is the average pressure? Average pressure into area is equal to total horizontal force. What are the takeaways or understandings from this? One is, when vertical height of water is given, water or fluid is given, irrespective of the shape, the pressure varies only with height of water or fluid column. This is one takeaway, very important observation from this question. Second is, when the sector angle is given, then for half portion of the sector, gate height is equal to, it is a very important observation. Do not make mistake in the examination for finding the height of the gate, vertical height of the gate. Gate height is equal to how much? Sin theta, what is that we have written? Sin theta into radius. Sin theta into radius of the sector gate. If the radius of the sector gate and angle is given, half height of the gate can be found out by sin theta into radius of the sector gate, whereas third, theta is equal to half of the sector gate angle. Because here only people get confused and make the mistake in the objective type. Don't make mistakes. Draw the diagram and do the answer. And horizontal force is equal to, what is the formula for the horizontal force? Half into rho g h square into width. Why it is h square? Because rho g h is pressure, and for force, average pressure to be taken, half into rho g h. HW is the area, where HW is the area, W is the width of gate. These are the takeaways, and please understand the concepts clearly, so that for whatever values in the examination the question is asked, to find out the horizontal pressure means we can find out like this. For a curved surface, finding the vertical surface, it has a different approach, and finding the vertical surface I will be taking up in the next class. You also do some homework before listening to this lecture. It is for the horizontal force, what is vertical force. Please do on your own, try to do. In the next class I will be taking up finding the vertical force on the curved surface. Horizontal force we have got, Now next step is to find out the vertical force. Once vertical force and horizontal force are known, then net force on the surface is equal to square root of horizontal force square plus vertical force square. This is the formula. Half of the problem we have completed today, and next half we will be completing the next class and finding the net force acting on the curved surface, including both horizontal and vertical forces. Best of luck to everybody. Thank you for listening to me, and if there is any value addition to your knowledge because of this lecture, please kindly share my lectures, view my lectures, and subscribe to my channel CIVIL-MECH-MATHS-CONCEPTS. Thank you.